Welcome to East Sweden and Visual Sweden, with a unique high density of researchers, competence and companies when it comes to visualizations and image analysis. In order to enhance innovation, Visual Sweden brings together companies, researchers and organizations with needs in so-called platform projects. One of them is the largest in the history of Visual Sweden. This is the story of the N-dimensional project.
We have gathered unique competences in the region to explore what can be achieved by using the partner's hardware and knowledge on sensors, sensor fusion, computer vision, AI and visualization. And we want to go from using single sensor systems to the next generation 3D models in order to see what new applications can be envisioned.
3D models are widely used in a variety of applications today, like gaming or city planning or other forestry industry and so on. And at the Swedish Police Authority, we wanted to introduce a scanning system like LiDAR sensor and optical sensor to be able to model crime scene. You can have a crime scene, for example, that is very large and very complex or need to be cleared very quickly, like in a traffic situation. So in 2017, we really were well prepared when the terrorist attacks occurred at Drottninggatan. We were able to monitor the entire crime scene that is more than 1 kilometer long, and that resulted in that you could actually see the crime as seen by the perpetrator. So you actually sit in the truck and see the whole event as it occurs over time.
The partners in the project represent the whole value chain from basic research to end users. Sometimes they are competing companies, but by cooperating for the joint vision we have achieved extraordinary results and a world-unique dataset.
Västervik is one of the few places in Sweden where it's actually allowed to fly drones, and we both have the city environment and the rural environment in the same place.
This is a new generation of 3D sensors. It's small, light and compact, and this is what people are putting on self-driving cars now. And we've been testing it for recording point clouds in a more convenient way. Currently you use a tripod and you put your LiDAR onto the tripod and let it spin a full circle. Then you move the tripod to a new location, let it spin again, and you keep doing this for like 50 or hundreds of times to get your full 3D model of an area. Here we can just put this on a stick and walk around to cover the area, so it's much faster.
We work with a technology called LiDAR, which is an active imaging technique. And it can be compared to radar, for example. So we send out pulses and we receive those and we measure distance and get a high-resolution image of the terrain.
With the APID-1 system, Mainbase has been the main provider of the platform for the air-based sensors. We have focused mainly on heavy sensors, multiple sensors or sensors with demand for high power. We have also contributed with our certified flight operations organization, both regarding personnel and expertise.
My group works more or less for the moment with 3D visualization, but also different kind of wavelengths. We have the sensors in the project working with the thermal visualization. We have hyperspectral imaging.
So we have a world-unique technology for three-dimensional thermal mapping. So the drone images are textured on the 3D model, and you can get out temperature values dynamically, where you can actually find heat leakages and problems with your building envelope.
For us, this has been a great opportunity to network and meet with people in the industry that work with all these kind of sensors and other types of 3D imaging sensors. It's also been very useful for us to see practical problems and to work at them and develop new kinds of basic science methods for them. So I would say that this machine learning approach to aligning LiDAR point clouds, that's something that's very useful for us, and we believe it will be very useful for others also in the future.
So far, with the data in the project, We have advanced in the technologies for positioning. So we use simultaneous localization and mapping methods to find an accurate position of the sensor and get the data in a very accurate geometric form. And we have also started using it for learning algorithms for machine learning to, for example, detect people in a forest.
With our 3D reconstruction technology and AI, we are able to reconstruct buildings in 3 dimensions and to texture them with normal images and thermal images and to interpret them with machine learning so that the building owner can get much more information about where they need to renovate.
We will continue to develop with other sensors and seeing different kind of sensors working fused is great. And the model that we will have as a tool from this project will be very great to have.
This project has strengthened the collaboration between organizations and companies in the region, and for us we have gotten a better understanding of new sensor technologies and the application and the possibility for us to meet the market in these sectors.
Well, normally we do acquisition on real cases. So here we have the opportunity to have a forensic artificial scenario that we can more or less distribute more open. So I have used this data set quite a lot actually.
So I believe in the future we're not only using images to create 3D models, but we use images, LiDAR and other sensor information and blend that to a perfect mix to create living digital twins of the buildings.
This project, with its unique competence and the unique technologies and sensor that all the partners have brought, we have shown that multidimensional models really can be achieved and actually can make a difference to an end user. However, we want to take this concept even further. Today, the concept of digital twins is very widely used and start to spread all over. You can have your digital twin for medical purposes, and you can have digital twins of entire cities for city planning or all kinds of application. But there is also something more you can do, as we did in this product. You can actually tailor your 3D model using the right sensor for the right problem, and thereby you can achieve a smart twin. And that is the twin that actually gives the information that you really require. So if you take a 3D model of a forest area, for example, and you can put out sensors for early warning of fire, forest fire. And what you really want is to detect it as early as possible to prevent the fire from spreading. So once you have a detected signal from one of the sensors, you can send out other sensors to monitor the spread of the forest fire using IR camera to see through smoke, using all kinds of other multiple sensors, as we have shown in this product, to consecutive information updating of your smart twin. So that's where we will go next. And this product has provided a unique partner cooperation, and all the sensors that we have brought together we should reuse in the next product and go from multi-dimensional models to smart twins.